Good morning and good evening. Same time. No, I'm just kidding. It's good night. Yes, I will enjoy that for a while on the introduction. That senator that doesn't know whether it's day, night, whether he's being asked a question is good morning, good evening. So, I want you guys, I'll release to you, beautiful people in the room, before I release to the public, the significance of the ductwork attachment at that wall. And I like to take pausing for, not for effect, but for you guys to catch on before I state it. The significance is, again, this is a flange. So let's do a profile of it. And here's your ductwork. This is the flange part of it that we see right here. And this flange material could be added later, the ductwork being flat, and then they just add these 90s on them. Here's extending into the wall system through the 8-inch wall, 8-inch block approximately. And that's that reveal there. And then they put a little bracket on it, screw in here, zip screw in here, or pop rivet would be better. Something that doesn't allow the obstruction in here and things to grab hold of. The detail's interesting, but what you're looking at is the shape of the system. And number one, you're looking at the shape of this wall connection. This wall connection. Let's just say you were to try, if you were to grab this wall, wait a minute, and push it this way. Just grab the wall system and just push it. And without removing the ductwork, what would happen? Just grab the wall and did a rotation there because it was going to go down. So, but if we could push it just in plane without it, just pushing it straight south, well, this would rip apart and etc., right? It would break apart. How about if we can just push it up in the air? Just push it straight up in the air somehow. Well, then again, same thing. You're going to see it rip here. How about if we could push it back? You know, we make fall back. Same thing again. You're going to get this deformed here. Now let's just say we can drive it down in this direction, sort of diagonally. This wall being inside an 8-inch block wall, it's going to mangle this section. This section is not mangled. So then now we have to look at how it was able to separate from the wall system. Separate from the wall system without destroying it. So this is critical. This one is critical also. Because again, there's no mangling going on here. It's just releasing. So to release it, you'd have to have that right rotation. Just a right rotation that would make this happen. A rotation in this direction would twist it. Rotation in that direction would twist it. A drop just straight down would tear it apart, right? Would make this fail. So the right rotation, the bending of the floor, the flexion of the floor, causes this to separate. So because this system is connected here, you have to, this is why I have the fracture going down around the middle there. Well, let's move it over. I'm going to pick on something that's structural there. And then we get our rotation. We have this steel. I'm going to change my color to red. 1, 2, 3, and 4, all integral to each other. It's found on the ground. All of this didn't. Let me see if I can do this for you. Hold on. So looking at the steel again, think of this as a cantilever, a pry bar. As this goes down, it has the ability to have a prying action to rotate this system up into the air, and it's anchored to the steel also, and it flips it. It flips it. As I show in the previous video, we see the steel at the top at that point, revealed at the top, and we see this at the bottom. we observe the angle here, the little corner. This is the previous video, and it appears, you know, in this drawing it's different. I mean, this rendering, it looks something like that. I'm not sure if that's an artifact or not. I don't have pictures of the roof detailed like that. So that rotation happens, and it just doesn't go down. It winds up somewhere approximately over here on the ground, maybe a little closer to here, and it could have just hit there and then rotated over, but then that would require double rotation. Hold on. So you guys now are observing that the ductwork is critical right here, and telling you how this failed. If you just went straight down, it would mangle this ductwork apart. We don't have data that shows that at all. It's showing that this is unmangled, if you will. If you just went down, it would have dented it. I spoke of the dent in the previous video, and I believe it's impacted here perhaps with a piece of block wall system that impacted it, and that rotation, etc. So let me make it be a little more clear as you look at this section here. I'm going to draw around it, and right here is a little, see the angle? An angle there, a little 22.5, a little 90 degree, 45. Sorry. Let me see that. Okay, there it is. So as we see the angle, coming here, we look at that. This is what I said. Look at this section, the angle piece. Here's the piece, and that's a cinder block on top of there, coming from this wall possibly, and impacting there, giving us that crease right there. It's like a cinder block right here. I mentioned how the legs of this, the stand of this is not right there. It's not broken. I mentioned that in the previous video. Please look at it. So we got some debris here that did get kicked in, and there's a metal ducting. There's that. We lost a parapet wall up here. In this image, I want you to take note of a folded piece of material up here, folded. So it's going to be a metal product more than likely, but folded over. Now we come to this image, and you notice the fold. The fold of this what appears to be skinned material, representing a door, and this looks like a hinge here. And it looks like a door jamb here. So closed position would be in plane with this wall, I believe. There's the coloration, so this is the inside of that wall, and that's the outside wall of when you go out into the radiator, the room there, out to the, where they have the AC units, I believe, up there on that one porch area. We take note of the block construction along with the solid poured material, concrete, and column and beam. Well, so much for that. I was recording and not talking. So let me just reverse and do it again. So the notches here, these are notches. Let me just show you what they look like now, like this. That's the block. And there's a little notch there, a little notch there, notch. This is typically done with some block layers where they'll knock that little piece out and they'll lay rebar in there and then solid fill it. I don't see the solid filling here, but I see what represents as the notching for that. These are solid filled. These are solid filled, and this is a rebar holding it together. So that's probably where that notch description I just gave you, how it goes across. And these guys are not presented, but this might be this one looks more like like one of these columns here. This one and this one, this little short guy. These look like That might be that one. So we would be looking for another one of these, this B section. We see the rebar. It's the way this failed. It gives a direction. The way it's pulled down, its rotation as it held on. It tells you direction of failure. That was what action held it and which direction it was pulled. This is probably still anchored at the base here, and so now that would give you your pivot point, your direction of your failure. And so this starts pointing towards that. These guys are not pulled away, but they're also not integral with the these guys. I don't see anything integral with the outer wall there. This one either. There's no rebar coming out of here. So that's why we see those in position. And this was integral and holding as it was pulled away, from the ductwork above. That's approximately where the ductwork is. It shows the direction, indicates the direction. Again, being anchored at the base. There's the folded door, so we're right below. The ductwork is above us here. I said I would give you the coloration issue I had with the other image in the previous video. Here's your coloration now. There's your parapet wall. This is your metal flashing. There's the anchors they use to put secure the metal flashing. This would be the parapet wall, possibly like that, if I can see the other color of it. Or this is the parapet wall. This is maybe the roofing material, and then it comes up and there's a flashing, and you've got this little parapet wall there. So this might be the walkway. This little section here with that little step, little parapet wall. So here is what I'm referencing. Approximately there's a metal door down here that we're looking at. It's still secure to here. I'm sorry, that would be back here. This is an overhang, remember, like this. So that metal door is back here. Folded over. Folded metal door. Looking to our left, image left. We have that beam that's like this that I described. So I need to find the base of this beam. It could be right about here. Could it be this one? Could it be the one that ties over here? It sure could be. And then that would still give us a direction, but I think it's too far, getting too close now to our door. The proximity here. I think that's too close. So our beam is back here roughly. There's that wall system. So it's back in line with the duct on this side of the right side, east of our image, more easterly. That is not over here, which would put us over here by this door. It's not here. That would still put us in around midline here. So I'm coming more to the right on that one. So in part 2 here, we see the ductwork is down on the ground now. There was up on the stands. Now they placed it. They put it down. I don't know whether they used the crane to manipulate that, but they did. So don't get confused if you find images in multiple positions. Here's our wall system that will start telling the story again. And there's that beam, that top beam system. This is beige, so I don't know what the inside hallways look like. I don't know where we can't see the other side of that either. So now we see the block in position. So there's your rotation, and it fell over. Again, don't. This is on the ground now, on the deck. So don't get confused. Now we do have a rotation, and it looks like a deflection of it. There's the top beam for that one. You can see the rebar holding it together. There's our folded door to your left. All right. Folded door to your left. Now I want to show you this. This will be the reveal in this one. Here to approximately, clearing it up. So here to, too much in line. I wanted to go above it. So here to here. There's your rebar right here. Look at that rebar indicating what the direction again. And there's your spalled wall. I talked about that in the previous video. Our rotation, our tearing away from the wall here of the tearing away, not just dropping away, ripping off, not just dropping away, but rotating away. And to rotate away and then change directions at the same time, because this door was rotated. I would not guess an impact here did that fold. I would guess it would be out here. It took a lot of load. It resisted back here. It buckled here as it was resisting. You see the buckle, the crease? I'm going to remove it right here. The door buckled there as it was impact there, and then direction or how before it slammed it to that position, and more debris and more rebar coming down right here folded that door over. There is the material that folded it over, that rebar. That rebar tells you the story of the interaction of this wall system. The door is in this wall here. It's a small little wall right there. And remember, this is, you can go and walk under this roof. This roof is not in plane back here. This structure cantilevers over. As you can see, the cantilever like that. Cantilevers over. And the door is on this wall, the wall system here. So that wall. And there's a rebar there also. So there's a little beam they put there because there's some rebar reinforcement, but it's lower. It's down by the door. It's lower. It's not at the very top. And then a parapet wall goes on top. Parapet walls are these little walls here. So here I want you to see that extent, like I said, that extension out. Take note, there is a false extension, a false look, if you will. The detail there. And this is where the steps were connected. And then I want you to also note that this is a recess, this door. So this roof was loading here downwards. Probably loading back like that. Supporting like that. And then in here, this is just a panel, the system that is false. It's just a set back, which I like. I like how they set it back like that. It's better than trying to match it up. Back then, they weren't really into fiber mesh or anything else like that then. It's too new. All right, so you can see the details, and that's the door. The door is not the door up above. You see it's square. It looks like it can open. It looks like the reveals are perfect. There was no rotation up, pushing up at that location. That rotation was, once you try to rotate, you automatically start pulling away. You can only have the lower heel part of the structure start pushing up, but anything at the top just pull away. So let me just show you this. And I'm going to just rotate this book. Grab a book and rotate. You'll see only your heel section can start pushing. And I call the toe. That's the toe. The heel's back here. So let's say that's the heel now. Let's reverse that. That's the heel, and the toe will start kicking up. But this is rotating away, so it's pulling away. And that's why you see that what happened there. So here's the toe. I'm going to go back to calling it toe. And that's the heel, the heel rather. Two E's. Two E's. It's not an A. So anyway, the other one, the heel's people. This is the heel of a shoe. So the heel rotates over and does this fracturing like that. It didn't, so what's important about this is in plane like that, the heel, this identifies my crack. What's important about this heel difference is that means this gives me my rotating panel down. You can extend this out to here perhaps. But that rotating, that book I just described to you, creates that gives you all the results here. If you were to try to turn it this way and now have this book, if you will, in this capacity, and you rotate this panel, because it has a roof, it has other engagements to it, you start rotating it clockwise. So in this case, top of the building would be north, this would be south, this top of the building, okay? This would be west and east. If you were to try to rotate this north to west, then you would start losing the ductwork, because the ductwork would be torn off, right? This structure here would have been rotated somehow. It would have been, I would see that, remember that little false panel piece? I'm going to get back to it. If it was rotating, it might have kicked off, torn some of that away, deformed that little end, and I'll show you the end in just a moment. That's why I don't have it rotating north to west, but I have it fracturing in this plane. So it would be, if you're looking at the top now, it would be east. So, yeah, right. I'm not going to do two directions on this one with you. This would be confusing. So, not to you, because I'm trying to orient you, and I don't want to give you two orientations yet. It's not fair. So this is not as we were looking from easterly through the building, and we were standing here, looking this direction. So that route, and we were standing there and able to see the cutaway view, as in the collapse shows, as if we're standing here, and this would be the north there, and east would be to the right. So east, north, west. So the rotation, if this structure was going down like this, north to west, rotating, I'd want to see some more indicators like that. More lifting, more scars, if you will, in that direction. Coming the other direction and falling away, so it's going to fall away after it starts breaking the floor there, and we get a direction there. Remember, if you do that rotation, the one I just mentioned, the other one, the other direction, you would get that ductwork rotating, and we do not have the ductwork rotating. So if you get it to butterfly in the internal part of this roof here, or again back here somewhere, like that. Oops, I'll do dots here and solid like this. And this is where your butterfly is like that. So that yellow line is there. And this is exaggerated failure. I'm just showing you the butterfly. This sketches are pulling away without having to tear the ductwork up. This gets us so we get this, the block work that's falling as a rotation. Some of that block work falls and connect it with the bond beams. They fall backwards into this section here. And some of it goes down with the structure. That rotation is able to reveal itself, flipping over the ductwork. That, once it becomes unsupported down here, or the counterweight of the concrete helps rotate that off and flip it off into the ground. I say counterweight, depending on how it was secured, because it's in cantilever, and the only counterweight is the weight of this being secured to the base, pulls down, flips it over. It's the last. It looks like it's last on the ground, so there was some delay, I believe, and to some degree, because this structure is down on the ground. It's not integral with it. It flipped over. And here the block I mentioned, the rotation, and your failure. Again, this is corrupted to some degree over here by the cranes lowering this down or knocking it down with whatever they used. But I think before this, pre-crane, it looked roughly like this per the other image I had loaded up. This is a fire escape rail. We'll get to this stuff. Looks like the fire escape railing, the handrail. to pre-crane there. Now you see it's elevated and it's on its braces, and there's that block wall system I spoke of. There's the rail system and the AC unit. Just for record's sake, I wanted to show the daylight between the roof line and the parallel in this image, meaning that you have to take in consideration the angle from the photographer of the lens. Remember that the center is, considering this is the center of the image, we're going to get the least corrupted area here, and as we go out we get distortion. But this is the center, considering people like to put their camera in the center unless it's a person's face, and then they're taught to use the 1/3 rule, which is photographers are taught this 1/3 rule. Put the person over here and have them, you know, this is wrong. You should put the person's face center and then crop the junk off and make a 1/3, because their face is going to be least distorted at this position. See many professional classes try to teach that 1/3 in that capacity. It doesn't understand the sensor. I'm going to end this video. Start another one in a few days for you guys, or posting in a few days. I mean, hopefully you enjoy it. The content. Take care. Love you. Bye. Thumbs up. Whatever you can do for me there. Thank you.